Hello fam, in this very class, we're going to be looking at another worked example on balancing complex redox equation. In our previous lesson, we worked on the first worked example and it was very wonderful. So let's look at what we have right here on the board. So today we are asked to balance ClO3 minus, that's aqueous, plus SO3 2 minus, another aqueous, now equals to Cl minus aqueous plus SO4 2 minus. We are asked to balance all what we have right here on the board in both alkaline or basic and acidic medium. So we are asked to balance this in both alkaline medium and acidic medium. So we're going to be solving this first in alkaline medium before we talk about, solving this in acidic medium. So what I'm going to do first, don't forget that the first is alkaline medium. That's what we are discussing. So how do we balance this in alkaline medium? So the first thing we're going to do is we're going to be writing out the oxidation numbers. So let's quickly get that done. The ClO3 minus, just aqueous, plus SO3 2 minus, another aqueous, gives us the Cl minus aqueous, plus SO4 2 minus, another aqueous. So let's get the oxidation number for each of what we have right on the board, the reactant and the product. So the charge on this is -1, that's the general charge. Oxygen is -2 naturally, so -2 times 3 is -6. So 1 atom of chlorine plus -6 equals to -1. So you're going to send the -6 to the other side. That is 6 minus 1, which is 5. So chlorine is +5. Oxygen is -2. Sulfur, what's going to be the oxidation number for sulfur here? Sulfur is -2 times 3, which is -6 to the other side. 6 minus 2 is 4. Sulfur is +4. Oxygen is -2. Don't forget that oxygen is not directly involved in this. Oxygen only complicates the whole reaction, and that's what you're dealing with, complex redox reaction. So on the product end, we have chlorine to be -1. Sulfur here, -3 times 4, -8. 8 minus 2 is 6, that's +6. Oxygen here, -2. So as you can see, oxygen has been consistent all through the reactant and now the product. Oxygen here, -2, and now -2. So now let's focus on the oxidation and the reduction. The chlorine here is +5, chlorine here -6. So what does that mean? It means there is a massive reduction from +5 to -6. So this is reduction, RED. So let's look at the sulfur. Sulfur moved from +4 down to +2. So sulfur underwent oxidation. That's an increment in oxidation number. Don't forget, we discussed all this already in our previous lesson. When there is an increment in oxidation number, we call that oxidation. While whenever we have a reduction in oxidation number, we call that reduction. So we have everything set already. We're working on alkaline medium. So what's the next thing we're going to do? Let's work first on the reduction. So the ClO3 minus, became Cl minus. That's -1. So this -1 power, then -1 also charge of power. So this +5 here down to -1. So how did we move from +5 to -1? It means -6 was attached to what we have here. So how do we attach -6 to what we have here? That means we're going to be adding 6 electrons to the ClO3. So that will be ClO3 minus plus 6 electron, which will give us Cl minus. This is what we have right here. Now the next thing to do is let's look at the number of atoms that we have on both the reactant and the product. So the chlorine is 1 atom. The chlorine also is 1 atom on the product, so chlorine is balanced. So where we have an issue right now is the oxygen. Right here on the reactant end, we have 3 atoms of oxygen, while on the product there is no oxygen. So how do we sort this? And don't forget what we said in our previous lesson, what we discussed, we said it already, that when it comes to alkaline medium redox reaction, under reduction, because this is what we're talking about, and this reduction we're talking about, under reduction, we're going to add water to the reactant, and then we're going to add hydroxyl and water, hydroxyl ion and water to the product end. So that's what we're going to be doing right away. You're adding water to this, and then OH minus plus H2O water also to the product. So that's going to be ClO3 minus plus H2O, unlike that's plus 6 electron. Unlike acidic medium, when it comes to acidic medium, on the reduction on the acidic medium, you're going to be adding hydrogen ion, that's H plus, and the water to the other side. But this is different. So chlorine here, minus, then plus hydroxyl ion, plus H2O. So we're going to put this two together in one bracket like this to show that they are together. So we're going to balance this off. H2O right here and then OH minus as hydroxyl ion plus water. So let's balance this. I'm going to be using my algebraic method, and that's why if you have not seen the previous lessons on balancing of non-redox equation, you have to do that for you to understand this. So this A, this B, this C, and right away we have our D. I mean, there's no need for the D, I beg your pardon. Don't forget, when it comes to algebraic method, we don't have to fill up the whole place. Just fill up all the reactants and product, then leave one of the reactant or product. So A, B, C, we're going to leave out this. So let's get our starts out. So chlorine, one atom of chlorine, which is A. Then another chlorine here on the reactant goes to one atom of chlorine here, which is C, the double chlorine. Then oxygen, three atoms of oxygen, which is 3A. Then plus oxygen, one atom, 1 times B is B, equals to, then on the product end, oxygen, we have one atom here, another one atom, that is two atoms altogether. No coefficient attached to it. That will give us equals to 2. So the next we have the hydrogen. Hydrogen is two atoms here, 2 times B is 2B. Then on the product end, hydrogen is 3 atoms altogether. So 2B equals to 3. So we have everything well set out. So we're going to solve this 3 equations simultaneously. So as you can see, the 2b equal to 3 automatically, b is equals to 3 over 2. That's what the b is. B is sorted already. B is 3 over 2. So if b is 3 over 2, don't forget a is equal to c. So if a is equal to c, quickly, whatever a is, that means it's also going to be the same thing. So we can easily get the value of a from this very equation too. So we have 3a plus 3 over 2 equals to 2. So we're going to collect our like terms. So send this to the other side. 3a is equals to 2 minus 3 over 2. So 3a is equals to, the cross multiply, 2 times 2 is 4 minus 3 over 1 over 2. So that will give us 1 over 2. We'll divide the both sides with 3. That will be 1 over 6. So our a is 1 over 6. And if our a is 1 over 6, it means our c also, since a is equal to c, our c also is 1 over 6. So we don't, get in the coefficients. So we're going to fill up what we have right here on the board with the coefficients we've gotten. So A is 3. A is 1 over 6, a bigger pattern. So 1 over 6 times ClO3 minus, plus the B is 3 over 2 times H2O water plus 6 electron equals to, the C is 1 over 6 times Cl minus, then plus OH minus plus H2O. Wow, we are very close to what we want. So 6, 2, and 6. So we're going to get the LCM. What's the LCM of 6, 2, and 6? That's a 6. So we're going to use 6 to multiply all through times 6. Then times 6 and times 6. Don't forget that this electron is not a part of what we are doing right now. We're trying to balance the equation, so electron is just there, just a spectator. So that will be 6 takes out 6. 2 here 1, 2 in 6 is, it's 3. So 6 takes out 6. And we're done. So what do we have? The ClO3 minus plus 3 times 3 is 9 H2O, 9 water molecules plus 6 electrons. And that will give us Cl minus plus, then we can share the 6 out in hydroxyl ion and water. Then plus 6 H2O. So we have this already. This is balanced. So let's see if it's balanced. Chlorine, 1 atom, 100% balanced. Oxygen is 3 plus 9, which is 12. So oxygen, 6 atoms of oxygen here plus another 6, so oxygen is 12, 100% balanced. So 18 atoms of hydrogen, 6 hydrogen here plus 12, which is 18. So this is balanced. So right away, we are going to be solving the oxidation. We are done with reduction, so oxidation is the next thing we're working on. So don't forget there's a result for the reduction, ClO3 minus, then plus NH2O plus 6 electron equals to Cl minus plus 6 hydroxyl and plus 6 H2O. So these are result for the reduction. So quickly, let's look at the oxidation. Oxidation is the next thing we're going to discuss. Don't forget that sulfur here is plus 4 minus 2 times 3, which is minus that is plus 4. While sulfur here is minus 2 times 4, which is minus 8. Sulfur here is plus 6. So SO3 2 minus aqueous became SO4 2 minus aqueous. So don't forget the sulfur here is plus 4. Right? Sulfur here is plus 6. So this is a clear oxidation because of the incremental oxidation number. So we have OX. So don't forget for the fact that 2 was added to this, that's why it's oxidation. So how do we explain the addition of 2 to this? This is how we're going to explain it. SO3 2 minus aqueous. So how do we add this 2 to it? That will be minus 2 electron, which will give us SO4 2 minus another aqueous on the other end, which is the product end. Now don't forget this, the sulfur here is one atom. The sulfur here is also one atom. So this is very simple, it's balanced. So if the sulfur is balanced, that's fine. But we have an issue with the numbers of atoms, with the numbers of oxygen, I beg your pardon. So 3 atoms of oxygen, 4 atoms of oxygen. So how do we balance this? Don't forget that we're working on oxidation. This oxidation we're working on under alkaline medium. So for us to balance this, we're going to do the opposite. For the reduction, what did we do? We added water to the reactant and hydroxyl ion plus water to the product. But this time around, you're going to be doing the opposite. You're adding hydroxyl ion and water to the reactant and then water to the product. So that will be SO32 minus, which is aqueous, plus OH minus plus H2O, then minus 2 electron equals to SO4 2 minus, then plus water on the other end there. So quickly, let's balance this. This is A. I'm going to leave this out. This is B, and this is C. So let's balance it. So the sulfur here is one atom. 1 times A is A. The sulfur equals to sulfur here is one atom also. Forget this B here, coefficient. So A is equals to B. So then there's the oxygen. Oxygen is 3 atoms. 3 times A is 3A. Oxygen here is 2 plus 2 because oxygen here is 4 atoms, 4B. Then plus oxygen here, 1 atom, 1 times C is C. So what's next? The next is hydrogen. Hydrogen here is 3 atoms. No coefficient attached to the hydrogen here. Just 3 equals to hydrogen here is 2 atoms, 2C. So we're done with all the atoms of element. So we're going to take this off like this. We're going to attend now simultaneously to what we have here. So 3 equals to 2C. So if 3 is equal to 2C, it means C would be 3 over 2. That's the value of C. Don't forget that A is equals to B. So we can easily get the value of A here. Hence, we've gotten the value of C, which is 3 over 2. So 3A plus 2, 3A plus 2 equals to 4B can also be 4A plus the C, which is 3 over 2. You're going to call it out like this. We'll send this to this place. We'll send this to this place. That'll be 2 minus 3 over 2 equals to 4A minus 3A. So 2 minus 3 over 2 will give us 1 over 2. You solve that, just cross multiply minus 3. So what do we have? 4A minus 3A gives us A. So don't forget, the value of A is 1 over 2. So if A is 1 over 2, it means B also is 1 over 2. Good. So the next thing we're going to do now, we're going to take off this very portion. Take off this very portion. And then we're going to fix all those coefficients into what we have right up there. So we're going to do. So let's fix our stars, our coefficients. So A is 1 over 2. So that's 1 over 2 times SO32 minus aqueous. Then plus OH minus plus H2O. Then minus 2 electron equals to the B is 1 over 2 times SO4 2 minus plus the C, which is 3 over 2 times H2O. So what do we do next? We're going to get the LCM of all this. It's LCM of 2, 2, and 2. So LCM of 2, 2, 2 is just absolute 2. So here times 2, times 2, times 2, times 2. So 2 takes out 2, 2 takes out 2, 2 takes out 2. What do we have left? We have SO3 2 minus aqueous plus, can share these 2 out of them, 2 OH hydroxyl plus 2 H2O minus 2 electron equals to SO4 2 minus plus 3 molecules of water. So let's see if this is balanced. Sulfur here 1 atom, sulfur 1 atom, oxygen 3 atoms plus 2 here, which is 5, plus another 2, which is 7. Oxygen here 4 atoms, oxygen here 3, that's 7 altogether. 100% balanced. The hydrogen, two atoms. Hydrogen here is 4. 4 plus 2 is 6. Hydrogen here is 6, 100% balanced. So we're done with this. This is how to work on the oxidation. So this is balanced. So the next thing you're going to do right away, you're going to bring them together and solve them simultaneously. So let's solve this simultaneously. And don't forget, we have 6 electrons here. Don't forget that this was the very first, there's the reduction result, and now there's the oxidation result. So on the reduction end, we have 6 electrons. On the oxidation end, we have 2 electrons. So how do we eliminate? Don't forget, we're going to try to make the electrons have the same coefficient. So there's 2, there's 6. So what we're going to do, the best thing we're going to do is we're going to get the LCM of 6 and 2, which is 6. So 6 divided 6 is 1. So we're going to multiply this with 1, and 2 in 6 is 3. We're going to multiply this with 3. So when we do this, we're going to end up having the same coefficient for the electrons. So 1 times all this out there. So that's going to be ClO3 minus plus 9H2O, the 6 electron. Then that will give us CO minus plus 6 hydroxyl plus 6 molecules of water. So we're done with that. So the 3 multiplies all this also. That's going to give us 3SO32 minus plus 6 hydroxyl ion plus 6 molecular water, then minus 6 electron equals to 3SO42 minus, then plus 9 molecules of water. So you're good to go. So don't forget, as you can see, the electrons are the same. We have the same coefficient right away. So how do we eliminate them? Plus 6 minus 6. We're going to add them together. We're going to be adding them up. Plus 6 electron plus minus 6 electron gets eliminated. So we're going to add up the rest. You add up all the reactants and then add up all the products. And let's see where we're going to go from there. So that's ClO3 minus plus 3SO32 minus, then plus 6 hydroxyl ion molecule. Then what do we have here? What do we have? Right here we have a plus 9H2O. Right here. Also we have a plus 6 H2O. Don't forget what we're working right on. So don't forget we have hydroxyl here, we have this, and then equals to the result. We have a Cl minus plus 6OH minus plus 6H2O, then plus 3SO42 minus plus 9H2O. So from this, as you can see what we have right on the board, we have some stuffs on the reactant end and some result on the product end that can take out each other. So 6 hydroxyl ion here, while on this place you have 6 hydroxyl ion also. So you can easily have them eliminated like this. So 9 molecule of water, 9 molecule of water. We're going to take out each other also. 6 molecules of water, 6 molecules of water, equally taking out each other. So everything is well set out. We're done. As you can see, the remaining result on the board is the balanced redox equation. So what do we have? We have a ClO3 minus plus 3SO32 minus. Then what do we have? All these are gone. Good. We have the Cl minus. Then we have the plus 3SO42 minus. Then plus nothing else. You're done. That's just that. So this is our result. As simple as that. So ClO3 minus plus 3SO32 minus. All this all eliminated, one another. And equals to Cl minus. Then plus 3SO42 minus. As easy as that. So this is our absolute result. This is the balanced redox, reaction or redox equation. Okay, guys, we've come to the end of this very lesson. At this very point, we're going to be drawing the curtain in today's lesson. Don't forget that we are asked to balance this very redox equation in both alkaline and acidic medium. So we've completed this already in alkaline medium. So in the next lesson, we're going to be solving the same question in acidic medium. So if you've gained 1 or 2 things from this very lesson, I would love you to give me a follow at Revelation Hub on Facebook and subscribe to the very channel at EduMosaic. And please share this lesson also with others. See you in the next lesson. Thanks and bye for now.